Okay, we're Team9. Radar is the name of our project. I'm Wanda.
I'm Danielle.
I'm Max. I'm Will.
And Professor Aflatuni in the EE department is our advisor.
So our vision with this, if you didn't catch it the first time, we're creating a portable system where we want to measure specifically a stationary person's respiration rate. And yeah, so we're using an ultra-wideband radar system to do this. Oh, and communication, yeah, we also use Facebook Messenger. It's really great, Sid, I would recommend. We also have a group GCal, which is really great. It keeps us on track. And then for our advisor, Bruce, he travels a lot, but he actually meets with us every Wednesday at approximately 11:10 a.m. And he also has these PhD students who are really awesome, and we set up emails with them and meetings with them they all use Steve's webmail, but I use Gmail. Yes.
So on the hardware side, the first thing that we're doing is making the connectorized version of the radar system. And the final version that we're going to be doing is going to be on PCBs. So the equipment that we're using is the pulse generator, VNA, and an oscilloscope. And the budget estimate that we're looking at is also like a few $1,000s, I think, because right now the parts that we ordered were already like a few $100s. And for the final version, we're going to be doing this on PCBs, which, like, depending on the materials and how many runs we're expecting for that, we're expecting that to be like $1,500. And also components around $1,000, but that also depends on, since we're using high frequency components, the manufacturers that make them, they are pretty expensive, and some of them have minimums on them, like you have to buy 20 or 30. But we also think that we can get some of these like expensive materials and parts that are like fancy and far donated. So we're gonna try and do that. But that's the budget we're looking at. And for the standards, there's a spectral power limit for ultra-wideband radar, which is basically the power that you can transmit the radar at. So that's something we have to comply with, but it's also different for indoor versus outdoor, so we shouldn't have any problems with that. And then on the software side, most of everything that we're going to be doing is going to be either in MATLAB, Simulink, or Python. So the budget estimate would only be for a Raspberry Pi or some other microcontroller which we might use for the signal processing side. So.
In terms of our fall timeline, right now we are working on the connectorized version of the system, which is basically just high-level modules, kind of proof of concept. So throughout the end of November, we're going to be characterizing that system, so taking measurements on the system components and antennas, and doing a link budget analysis, so basically seeing the signal propagate through our channel, which is the air, and to our other antenna. So that is our plan for what we plan to demo in this demo day, and then after that, the plan is to start working on the PCB version of the radar, and hopefully send out a first iteration of the PCB for the end of the fall.
For our spring plans, our first plan is to finalize the PCB design, translate the connector system onto a PCB, finalize the algorithm. Our first iteration is just going to be returning the distance to the target, and then the finalized version will have the calculations that will turn that distance into frequency of respiration. Beyond that, it will be translating our code from a MATLAB computer onto a microcontroller, and at time permits, we'll focus on more lofty goals, such as measuring different biosignatures like heart rates, measuring target through a wall as it's moving, or maybe even systems that we can handle.
Thank you.